My name's Jason Donovan. I'm a physicist. One of the things that physics loves to do is reduce complicated systems down to their simplest possible components. I'm going to take the most complicated system of all, the universe, and reduce it down to a ridiculously simple model. I'm going to assert that the universe is made of matter and energy. Matter is stuff, and energy is the ability for that stuff to move or the actual motion itself. So for example, if I have an apple, the apple is stuff, it is matter, and this matter, if it's moving, that's now energy. Or if it's up here and it has the ability to fall, if I let it go, that's energy as well. Or if I eat it, that gives me the energy to be able to move, and that is also energy. So the entire universe is matter and energy organized into a particular structure. If the universe is nothing but matter and energy, then we can say things happen. And these things that happen, we're going to call processes. So the processes can be anything. A car starting, a rock tumbling down a hill, someone eating an apple. Any process that happens is a rearrangement of matter and energy. So that means we have a certain input of matter and energy. And it starts off with some structure, some way things are arranged. And then the process happens, the rock falls down the hill, what have you. And then after the process, we have some output of matter and energy. Normally, the total amount of matter, the total amount of stuff that we start with, and the total amount of stuff that we end with is going to wind up being the same. And the total amount of energy that we start with and the total amount of energy that we end with is also going to be the same. We had taken this to be true. Physicists really hung their hat on this, and then Albert Einstein came up with a revolutionary idea a little over 100 years ago, where he said sometimes matter can turn into energy and energy can turn into matter through his famous equations, E equals mc squared. This showed an equivalence between matter and energy using c, which was the speed of light, squared. So there's a huge amount of energy released every time we make some matter disappear, and it takes a lot of energy to make any kind of matter appear. So that's why we hadn't noticed it until the early 20th century that there was this relationship. But the big thing is any process in the world can be, or in the entire universe, can be thought of as a certain amount of matter and energy going in and a certain amount of matter and energy coming out. Society uses energy and matter. We get this energy and matter in raw forms from nature. What we then do is we transform them. And we transform them into other types of energy and matter. This allows us to have everything that we have in our life, even our own bodies. The electricity that we use, the cars we drive, the clothes we wear, all of that is energy and matter that we're getting from nature. There's some wonderful upsides to this. Reduction of poverty, the ability to treat diseases. It's amazing, but there's downsides as well. This series of videos will talk about the energy and matter that we get from nature, what kind of transformations we undergo, what energy and matter we use in our society and why, and how that's really having a big positive impact on our lives, but also how there is a downside to all of this as well, including and most especially climate change, which is changing the world that we live in an unprecedented way. This is going to be a fascinating journey. It will challenge the way you think about society, but I encourage you to stick with it because I think this is going to be interesting and useful.